Hello, and welcome to Ben Elliott's ENME351 Lab 9. So the idea for my project was to take a very noisy input signal, run it through a low-pass filter, and then be able to control a servo motor in a smooth and steady fashion. To create the noisy signal you can see here, I used the N-scope from ENME350 and ran it through a summing op-amp circuit, which I found on dummies.com. And then input it into the Arduino via a low-pass filter. Here you can see the circuit diagram for the low-pass filter. So when omega is less than 1 over R times C, the gain is approximately R divided by R1. And when omega is greater than 1 over RC, the gain is approximately 1 divided by omega R1C. And for this circuit, we used an R and R1 of 17,300 ohms and a C of 10 microfarads. This was chosen to give the omega cutoff of just below 6 radians per second. Here you can see the physical circuit where this is the low-pass filter, but the low-pass filter also inverts the signal. So then I used a inverting op-amp with a gain of 1 to return the signal to a positive voltage. The movement of the servo motor is based on the amplitude of the input values read by the Arduino. So when you can see that the low-pass filter is implemented in between the noisy signal source and the Arduino's analog input, the servo moves in a smooth and steady fashion. Next, we'll look at what happens when the low-pass filter is removed. You'll see that the motion of the servo is very jerky and uncontrolled. In order to demonstrate what the servo motion looks like when the low-pass filter is not used, we have skipped the low-pass filter of the circuit and put the input of the Arduino directly to the summing amplifier. So you now see the motion of the servo motor when it is not being filtered. As you can see, the motion has a lot of noise in it. It is not smooth as we would hope, and it is not particularly usable. We can also see the benefit of using the filter in a visual manner through the data, where the Arduino will send the input values, one read directly at the summing amplifier and the other read after the low-pass filter, into the serial monitor, where it can be read by processing and plotted with time. And as you can see, the filtered signal produces a nice smooth sine wave, while the unfiltered signal certainly has a sine wave of the same frequency. However, the individual readings are unconnected and would result in the shaking motion of the servo motor.